Stop. All right, let's get Zoom started. Record.
Recording in progress.
Share screen here. Zoom sometimes fails on its record, so I'm trying to record on my own computer too, just in case that happens. Modules, what are we doing today? We are starting chapter 2. Before we start chapter 2, I'm going to comment this out real quick. In fact, let's close it and just restart it. Remind you guys all how to get there. So when you open up Visual Studios, remember you're going to want to open up a new project or access a local project. But if you create a new project, let's do that. You want it to do console app, and I'm going to tell it C++ in particular because I want it to be an empty project. That's what I want to get. Empty project right there. That's what we want. That's the sweet spot. So we'll start with that. And let's call this our lecture for 2A. And notice it's defaulting to a spot. Everyone tends to default to repos. I don't like going and tracking that down, so I'm going to browse and find where I was doing it. I was doing lecture notes on my desktop in CSCI Labs, and we'll just do it there. And I'll click Create. And we gotta do a new source file, so I'll say Add New Item, and call it Lecture 2A, why not? And C++, good to go, add. So something, what did we have? We always have the include.
Can I shoot out a question?
Yeah.
What was the significance of grabbing the console app versus the empty project?
Console app was the wrong thing. It's the empty project.
In
my head, the empty project is an app on the console, but we definitely want it to be empty.
Okay.
So we want to include the IO stream. And we're going to do using namespace std. And I want to give you a little rundown of why. We're not going to go into namespaces very much right now. But let's just get a blank program done. This is like the most basic program you can do. Let's just make sure it runs before we get started. Good, it ran. All right, everything's working. All right, so namespaces. When you're going through the source material on like C++.com and stuff like that, oftentimes you'll see stuff like this, std : cout. Then you'll see the insertion operator, hello world. And then you'll see std and like that. And how does that compare with what we've been doing right here? Let's give it 2 exclamations there. When I run this, ooh, my Zoom camera's in the way. There we go. It runs both. And if I turn this cout off and I turn this using namespace off by commenting them out, well, let me do this first. I'm going to comment that one out first and try to run this one without using namespace std. If I try to run this without using namespace std, build errors. I have tried to access a library that I don't actually have listed. So I'm going to comment that out, bring this in, uncomment that one. Ooh, undo. There we go. And now if I try to run it, what happens? It still ran. Notice I've got using namespace turned off. It's commented out. But I've got this std : so when we're using libraries that we haven't done the namespace for, or when we're using content from a namespace we haven't included above with the using command, we need to tell it where to get it. And that's what we were doing with the standard cout right there. This is more like what library : what command from library. Okay, that : right there, we won't use it for a little while, but it'll come back up when we start doing classes and stuff. This is called the scope resolution operator. And it helps figure out what scope, what library we're using. Notice this altered the capital casing that I did there. Is called Camel Case. Or Camel Case. You capitalize the first letter of every word. And leave no spaces. It makes it look like it's got humps. If you look at it like a hump on a camel, there's the capital letter is a hump. But what it does is it allows you to make more complex variable names, and we'll look at that in a second. Well, hell, let's look at that right now. If I wanted to go with, let's see, what example did I want to use? If I'm making we haven't done integers yet, but we're about to. I can do two-type integer a couple ways. I could just say, I could type this, and I'm not going to read it out loud. Oops, I need a space there at least. Or I could say this. This one tends to be more readable. So we do it for readability. Why would I want to use a name for a variable that really long? Probably not, but I might want average age or age of college student or something, age of student, because I might have several people I'm looking at the ages for. So sometimes having more complex names is helpful. Let's take a look at variables. Let's look at variables. Let's start with a comment section. Let's look at variables. And think about in math, we like to use X and Y. And we have functions like y equals f parentheses x, which equals like 2x plus 3. And x is our variable, input variable, and y is the output variable. And we can actually see that here on my screen. Main is a function. It's a function like f of x. I've got main void, which means it takes in no input. And outside it says int. Int is the output. So we'll do more on functions in section 3, but we need the variables first. Variables are similar. Here, x can be any number though, right? I can use integers. I can use rational numbers like 2.75. I could use irrational numbers like pi. Each of these, just like writing it on paper, takes up different amounts of space. But in computers, unlike writing in your notebook, often space matters. Hard drives matter, they fill up. So, what we do is we separate numbers into categories. Numbers get separated into categories. The first category we could do integers, which goes by the command int, followed by the variable name, and then a semicolon to end the line. This right here, this declares x to be a variable of type or data type integer or int. And the reason why we do that, integers take up only 4 bytes. 4 bytes, which is 32 bits of data. If I want to do a number, something more complex like pi, or even just a long number that but ends 3.5624, and that's it, it's going to take up more space, and we have a couple options for that. We could go with float. Float is an option, and I'm just going to give it a value here. Here, I've declared y to be a floating point integer. Or a floating point number, sorry. And initialized it to 1. And just to test something real quick, we're going to see out x, and we're going to see out y. And I'm going to turn using namespace back on. And see what happens. There's an error. Some programs will run this, okay? So here, the problem is on x. Problem with running here is with x. X has not been initialized. Some computers or IDEs initialize it to 0 or garbage, really. Whatever was already in that memory. Okay? But my system and this IDE, it does not. Sometimes it initializes 0, sometimes it doesn't. So if I want it to work, I can actually declare or initialize x or give x a value on another line. I could say x equals 3 here, and now it will run. If I click run here, it runs. Okay. We don't use float that often. Look at that. I didn't put my comment in. I'm missing a chat thing. What does it say? How do you start a new program? You have to... Is that an old question or did you see me do it? JJ. I'll walk you through starting a new project later, or new program later. Let's just get through it right here. We got time stuff going on. Float isn't used often. We use double. Double is a favored one. Double Z. I don't need to declare one at a time. I can say double A, B, C, D. I can, declare a bunch at once. Double here means double the precision for decimal places I can use over float. And we tend to like this one. We like double. So I can initialize it like that or declare it like that. I don't need to do the values one at a time. I can say A equals 5, colon, B equals 6. And that'll initialize both of those. I can do C equals D equals 10. And this assigns 10 to both C and D. So there are little things you can do to speed it up like that. But we were using double, so let's maybe make this a decimal. 10.13. And I'm going to change A to be 5.95. And B equals 6.2. I don't have to, though. I can leave I can put an integer in as a double. Here, B will be recorded as 6.00000, keeps going. But doubles take up 8 bits, or 8 bytes, which is 64 bits of memory.
So I'm just kind of playing with this as you're talking.
Yeah.
And I put in, what do I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Got about 15 spaces or 15 values after the decimal for a float. And when I run and it prints 5.
Okay, if you change that to a double, it's going to do the same thing.
Correct. It just did the same thing, which is why I was curious, because you just said it was double the precision. So
what's displayed and what's in memory are two different things. Since you're bringing it up, I'll show you how to do it now. If you want to display more memory than is given, display more digits than is default, we need to use include IO manip. So I'm going to go up there and put that up there, actually. I'm going to include IO manip, and I'll show you how that works. This is a library that manipulates the IO stream, or the input-output stream. So IO manip. Okay? And then when we do, I can come down here before I start introducing anything, before I want it to happen. In fact, let's try it out here. Let's say double F, or I don't need a variable to be a single letter. I can use a longer name, like double value of pi equals 3.141526. After those numbers, I don't remember what they are, but I'm going to just put a bunch down. This is an inaccurate number, but it's good for testing. If oh, I did not put my semicolon in. Look at that. Now let's do cout value of pi just to show you what David was talking about. Run it real quick. Not only did it chop it, but it looks like it rounded it, right? Because I had 3.141526 and it rounded the 2 to a 3. What happens if it would have been something else? Does it always round up? Let's change that 6 to a 4 there. Or a 1.
No, it doesn't always round up.
Doesn't always round up. Yeah, there it rounded down. That's handy. Okay, so if I want to display more values, you can do cout. Once you've got the IO manip in there, you're going to say fixed, and then you'll do set precision, no camel case there, set precision, and choose the number of decimal places that you want to show. And then end line. In fact, I don't even need to end line. I can go directly to showing, but I'm going to because I want to show you that it transfers to everything after that. Now I'm going to do the value of pi again. Speed it up just by copy paste. And if I do it now, I get more decimals. This is pretty handy when you're trying to get money and you want to round to the penny. But you're computing something that has smaller things like gas always has like 9/10 of a cent and shit on there. It rounds to the penny. So these come from the include IO manip. So we got let's see, we've done integer, we've done double. Integers are 4 bytes, double is 8 bytes. Float is 8 bytes also. I don't know if I said that. Float is 8 bytes. And that kind of covers all the numbers. I can't really, like, eventually, I can't really do irrational numbers completely, which is good to note, actually. We can't have accurate or 100% accuracy on irrational numbers like pi. We were restricted to the number of decimal spaces, the values that a variable will hold. Okay? So while you can write pi to 300 places on a piece of paper, they got to do some loopholes and jump through some hoops to get that to still work and calculate lower decimal places on pi. Let's see. We talked about the camel case. Let's look at some examples that are related to money. I can do a double. Whenever I type fast, my B never shows up. I do double my check. I'm going to use camel case so it's easier to read. My check equals 4,542.39. It's telling me I got an error there. In fact, when I hit the colon, it put a space in there. What's my error here? Any ideas?
The syntax error? Yeah.
Well,
Comma?
when we do money, we put in like a comma, right? Like if this was my paycheck, that is a heck of a lot easier to read. Like let's say my paycheck was in the millions. 3,424,542. We write this for readability. In English, for readability. But that causes a problem for computers. The comma is telling it something else is changing. So if I want to,
are you telling it that variable is those 3 different values?
Yeah, it's telling it's 3 different things.
Okay.
And we haven't done arrays yet or anything like that, and it's confused. It's like it's going to assign 3 to it, Like that top line, I have 3, 424. It's assigning the 3 to it, and the comma ends it. And the rest of it's like, what the hell do you want me to do with 424? And what do you want me to do with 542.39? So if I wanted to do the same thing, I have to type those without the commas. And that'll work. Not readable to us, not easily read by us. But this is what the computer demands. Okay. So I tried a comma. What if I put in just a space? Looks like spaces cause a problem too, right? So we don't want any spaces or any other symbols in our number. The decimal point is the only real thing you can put in a number. I can have extra spaces over here. I can have extra spaces over here. I can have, a return line there. And the computer doesn't care. But if I have spaces in a number, it's going to cause a problem. Having my code like this is junk, though. That's really hard to read for users. So you want to make your code readable. Try to be more clear and concise with your code. Keep stuff condensed, but not too condensed. Let's make it more readable again real quick. So no commas, no spaces in numbers. Good to know. What else can we write? What else can we print to our screen?
So quick question,
Yeah.
if I can. You put the cout fixed set precision 8 end line to set your printed precision on the display on the output.
Yeah. It's actually
is that going to apply to everything beyond that? So
yeah,
is that 3,400,000 and whatever thousand? Is that going to come out with 8 decimal places as well?
It should. But the easiest way to check stuff, just try it. Oop. It should maintain it until you change it. Okay. So the precision stays fixed. That's what the fixing it does. If you want to change it back later on, you can always add in a new set precision and stuff like that. Numbers aren't the only thing we use that we want to print and stuff, though. We print characters and sentences, right? We like to print sentences. Statements that make sense in English. These are called strings in programming. We will do strings on Monday. Let's go with the basic component of a string. The smallest component of a string is a character. Single character. So I can do like char is the command for character. Char is the data type. So char is the data type. I'm going to give it a name for my variable. First letter of name equals, and when we do chars, we use single quotes. Okay, so be sure for that. Be sure to note that char is single quotes But we've seen on the COUTs we use double quotes. When we did like a sentence, hello world, strings use double quotes. And there is a difference between lowercase and uppercase. So you want to note the difference. And I'm just going to illustrate to you something. I'm going to see out first letter. And then I'm going to do a space. I'll say equals. And then I'm going to do this. I'll explain after I type it. So all of the characters, the computer doesn't record characters. The only thing the computer records is numbers. So our letters have to be converted to numbers. And if I see out first letter, let me copy this and do the same thing for last letter, because I want to show you that first and last letter have different values, even though they're both D. All right, I'm going to see out both of these. I got lowercase d for first letter, uppercase D for last letter. It tells me little d equals 100, big D equals 68. Okay, this is according to the ASCII language. Ascii table. So I'll pause there for a second and then we can go look it up real quick. Because you can find this just about anywhere. All right, let's do ASCII table, Google. ASCII table. And images is probably easier to use. There's a lot. Finding ones that are easier to read. Let's try that one. Visit. So every character that we can type, including the space, has an ASCII integer value. We just saw that 100 was D. Wow, why is this not showing it? All right, I'm going to go to a different one. Let's go with that one. That's a little hard to read. 100 is over here. The decimal version is 100. The character is D. If I look at 68, 68 is capital D. So, and all of these things have commands, or all of them have an integer value for them. Like the backspace, carriage return, escape key, or escape, different stuff. They all have keys. And we'll be doing more with that later this semester, but that's how the computer stores it. So let's get back to our program. Capitals and lowercase are in different, capital and lowercase have different values. What I did right there by typing int last letter like that, I took the character in last letter and I cast it as an integer. That's the word we use. The words we use. Okay. And we can go the other way. We can cast integers to characters and stuff like that. Generally we don't, but that will come up later on. In fact, let's see how that works. We know that one of them was 100. Let's see out char 101. Let's see what the next letter was. So if I see out char, 101 is an integer. It's not a variable. I just put in a number. What happens? Gives me the letter E. It's going to that Ascii table right there. So that's a handy thing to have available for you. This prints E, which is 101 in ASCII. Chars only take 1 bit, or 1 byte, which is 8 bits. And we got another one that only takes 1 bits, or 1 byte. The last one, last basic or fundamental data type we have is also 1 byte. It's the Boolean. And it goes by bool. Bool is a toggle, like on off.
I'm sorry, I have a quick question about.
Yeah, go ahead.
I have a quick question about the chars. So for char 101, if we put E in there, would it print 101? Like, are they interchangeable?
If we did int E, it would do 101. I wonder what it'll do there. E, well, yeah, E has not been defined as a variable, and right now, if it's not listed as a character, I could do this, though. I could put it in, like, oops. So I can do char, but I have to, if I want to use a char, I got to do the single quotes. If I wanted to cast that as an integer, let me copy this real quick. I hate typing over stuff because it edits it and then I don't put it back later. So, nope, I had 101 first. If you do char parentheses E, that doesn't work. E is a variable. And going the other way, we can also do cout int E like that. So on this one, I am casting the integer 101 as a char. And on line 62, I'm casting the char E as an integer. Oh yeah, since it doesn't work like that. Wait, why? Oh, I didn't have a semicolon. There we go. Ta-da. So you can cast things as different things. And we'll do more with that later. You're just learning the basics of the variables right now. Let's do the Boolean. It's like an on-off switch. It is also used for true or false. So I could say bool G. I could say false, and see that false turns blue. At least in my IDE, it's an actual word. It's a word. It's a word in programming. What happens if I cout G? If I cout G with it being set to false, I get the number 0. So false is always 0. Or 0 is always false. For a bool or Boolean. Which is handy, because sometimes you will use stuff as numbers and go, is there 0 in it? Let's look at making one that's true. Bool H equals true. And let's see what happens when we see that one out. And true equals 1. in Boolean values. Okay, when later on when you're doing any test, when you use this in like if statements later on, any non-zero value is going to say true. Like if I tested the number 10, it would say true. So false is 0 and H is every other value. We'll use toggles more later. Those are the fundamental types. So integer is 4 bytes. Float and double are both 8 bytes. And then char and bool are 1 byte each. Let's take a look at some of the stuff we have in our notes section. Let me tab back over. Oops. Don't want to look at that one. Let's look at our module. Let's look at some of these special characters. Actually, I'm going to look at it. Some of those there. Quit highlighting it. And I'll make it bigger for the camera. You've seen the double slash marks. It's commenting. We've seen the pound sign. That's the preprocessor directive. We've used it on IOStream and IOManip. There are other things that we use it on later. We use those triangle brackets for including a directive, but we'll also use it later on for things like vectors and stuff like that. We use parentheses when we're naming a function, just like we did with int main. And the parentheses define what's inside is the input. When we're doing a bunch of statements, we'll end up using brackets to include it all together. You'll see that show up. Single quotation marks, there's a single character. Double quotation marks is a string of characters. And semicolon ends a programming statement. Back in the old day, programming, you had all the lines needed to be numbered, like 10, 20, 30. And if you wanted to go to a specific line, you could say go to that line. In fact, it still works here similarly. We'll do that later in the semester as well. I think it's a handy tool. And then some useful commands inside of string literals. We talked about the new line before, but I'll copy this and put this in here. Let's make a, oops, that's not what I want. So we can look at those real quick. See how this is a string literal. I can do slash new line. For slash n creates a new line. It's like n line. If I put spaces in, they show up in the printout. Here's my second line. If I put in a slash t, it does a tab. And here's the rest of my second line. I'll take a look at that real quick. So we've seen the new line. Rather than using n line, it made a new line. The spaces I typed in the string literal will show up on the screen, and the tab shows up right here. Shows up in there. If I add in the slash a, let's see if you can hear it. Were you guys able to hear it? I don't know if it played it plays a little an alarm beat. It's good for when you're programming for yourself and you're trying to find an error. It can help. If you send in an assignment with a bunch of slash a's in it, I'm going to give you a 0 because I don't want you blowing up my damn computer with alarm sounds. Don't mess with me. Let's see. Oh. Actually, I didn't need to do this. What happened? What happened with it? All right, I've got, here's my second line. The apostrophes show up just fine there. If I wanted to use an apostrophe as a character, though, I could do cout char. If I just try to do an apostrophe in here as a character, it doesn't work. It ends it. But if I do / apostrophe and then the second quotation mark, it works. So let me put some spaces in there so you can see a little bit better. I'm going to have to take it away in a second. The first one here starts the char. The one over here ends the char. This one I want to print to screen. And the way to do it is put a / in there. You're not going to use this one that often. Same thing if I want to print a quotation mark in a string. David said, and if I try to do quote, like you'd start a quote in English, it ends the cout. So I have to do / quote, math is awesome. And then I would do / end quote again. And then that quotation mark ends the statement. If I run those two, I run this, we'll see that the char line we did, it just shows the single quote. And here I was able to print out double quotation marks in a string, even though the quotation mark normally ends a string. So that was the purpose there. And backslash, if I want to show the backslash, well, I've been using backslashes here. If I want it to show up, I have to, like the first backslash says, oh, I'm looking for a command like N or T. So it's hard to do one like that, but if I do the second one, now it's going to say, oh, you want me to actually print the backslash, not use it as a backslash. And so that'll add a backslash in my text. So those are little commands you need in the strings that we're going to do later on. Those are pretty handy. And finally, we're going to take a look at the code we got. So we're going to go over to notes. Let me shrink that back down a little bit, get down to 100%. This was talking about the space it takes. Char is 1 byte, integer is 4 bytes. We're going to do this arithmetic examples demo. I am going to copy the whole thing. Actually, let's just copy this part. Or right click. So, doing arithmetic demo. So I'll paste those in. I've already got the include and the using namespace up top. So let's go ahead and take a look at what's going on here. Let me include a bunch of end lines so that it makes a space on my screen. So here I'm declaring user number 1 and user number 2 as an integer. I'm declaring quotient as a double. Those are data types. And we're seeing it's going to say arithmetic operators demonstration. This says it's going to make a new line. And end line is going to make a new line. So there should be a space between them. Please enter an integer. And then we have the cin prompt, the input command prompt, and the extraction operator. And then we do that again for user number 2. We'll do that again. And then what does it do? It says cout, it says the sum of, and then it puts user number 1 there. So it's going to post what we store in user number 1 to the screen. And then this part says put the plus sign on the screen too. Then put our second stored user number there. And then we've got equals here. And here it's going to perform the operation. It adds up user number 1 plus user number 2. It's not going to print out plus sign in it. It's actually going to add them up. Difference is subtraction. Sum is addition. Product is multiplication. And quotient is division. Let's just go ahead and run it and take a look what happens. So it says, please enter an integer. Let's go with, I don't know, 20. And enter another integer. Let's go with 7. It tells me the sum of 20 plus 7 is 27. Good. 20 minus 7 is 13. Good. 20 times 7 is 140. Well, no, that's good. 20 divided by 7 is 2. Is that right?
Not technically, no.
No, it's not
20.
right. What's happening here?
It's rounding.
Not only is it rounding, but it's, if we did 7 divided by 20, it goes in, we do 14, we got 6 left over, right? We've got 6 sevenths left. So this value here is technically, see if I can annotate. That is 2 6/7. If we round, would be 3. So it's not rounding. What it's doing is it's taking just the quotient and ignoring the remainder. So let me clear all that and type that. So when it gets there, this is just doing the division and recording the whole number. Why? Why was it doing that? Well, user number 1 was an integer. User number 2 was an integer.
I was going to say, because you're using integers, it's basically just saying,
it's saying
you want how many times can this integer go into this integer? And the answer is 2.
Right. So it's trying to make the outcome an integer. So we can see ways to deal with that. I actually typed them in down here. One way is to do where we cast one of them as a double. Here I said I cast user number 1 as a double when I did the division. You don't have to cast user number 1 as a double. You could cast user number 2 as a double. It doesn't matter which one you do. As long as one of them is a double, the whole thing will be a double. Another way of doing it is, rather than casting it, just saying multiplied by 1.0. 1.0 is a double. Multiplying by 1.0 doesn't change any values. But since 1.0 is a double, now it's all a double. So you have a couple ways out with it. And then we have one more thing on the screen that we'll talk about. Got to do it again real quick. Oh, let's do it. 20 and 7 again. This line right here. 20 parentheses 7 equals 6. We just got done saying 6 was the leftover. Is this thing always the leftover? Let's try we know 15 divided by 7 should only have 1 leftover. Let's try doing 15 divided by 7, see if it changes. It's giving me the remainder. So this percentage symbol, which is being used here, percentage is called the modulo operator. And it yields the remainder left over from division. It's also known as modulus in math. And this is something that you actually see a lot in your courses. Or not, you see it a lot in your real life. unless you've only ever seen a digital watch. Every clock that has 1 to 12 on it does modulo arithmetic, basically. Once it gets to 12, it doesn't go 13, 14, 15 like military time. It resets back down to 1. Well, modulo works very similar like this. If we're going to do like x modulo, I'm going to type modulo or percent, 26. So x percent 26. The only possible values are 0, 1, 2, 24, 25. All the way up. 0 through 25. Once it gets to 26, it subtracts 26 and keeps going. Okay? So it's slightly different than the way we look at clocks because we don't have a 0 on a clock, but it's the same idea. And it's actually a handy way. This is very handy later on when you're trying to tear apart strings and put them back together again. Maybe making no capitals or first letter capitals in a string. You can program that in where it does it for you. And doing this, we'll cover that later on. We haven't even done functions or anything like that, but the modulo thing comes in handy. So it gives you the remainder thing. All the arithmetic signs work as intended. Plus is plus, minus is minus, multiply is the star symbol, the asterisk, and the backslash is division when it's between two numbers. Just keep in mind, I said this out loud, but I didn't type it. This is integer division. Dividing two integers results in an integer. Integer. So we deal with that below. And that's what we did here. Different ways to cast integers to a double to avoid integer division. I could make one more because I said it out loud, but I didn't actually show it. I said I could put this one in a double. And I can take this one out of the double and it'll still work. So I'm going to run it again. There's one more thing I did here that I haven't actually explained, but I want to real quick. My Zoom camera keeps showing up in the way. So let's do 20 and 7 again. Notice when we look at the actual division, it's showing we get the same thing either way. This one, this line right here, we had double on the first one. You can see that right here. The second line, we did double on the bottom one. And here we multiply by 1.0. So there's a couple ways to do it. I do want to point out something else this did. So let's close that real quick. Notice I've got quotient here. And I'm seeing out I do a C out on line 114 of the quotient there. But you don't see any line that starts with me saying quotient equals so-and-so. Except notice right there on 103. When I did here, I put this in parentheses. This is why I put this in parentheses. I didn't put these other ones in parentheses. You can, it doesn't change anything. But I put these in parentheses, and what this says is do what's inside the parentheses first. Set quotient equal to user number 1 divided by user number 2. So I set quotient, and then it's seeing out quotient. And so when I do it later on, when I see out quotient down here, it does that same thing. It shows it again. And when I reassign it in each of one of these, I can see out quotient there. Catch you later. Oh, you're not leaving yet. Okay. See out quotient. We'll see that it changes value. Even though I never did it on its own line, I did it as a subset of a line. Let's do just 7 and 3. The integer division gives us 2. We have a remainder of 1. The quotient is stored as 2. And then when I was doing the real divisions, I put the quotient in the text over here so that it would store there. And you can see that it's a stored quotient there. This is a little bit of saving some space. I could just as easily do the following. So when I was here, I could do this. I'm going to say quotient equals and here I can just say C out quotient. So the way I've got this written, the line before this one and the 2 lines after do the same thing. Sometimes you can sneak stuff in there. To be honest, you'll probably gain more out of doing it like this for a long time. I did want to show people that are more comfortable with and learn faster or work faster, other ways you can do it. Obviously, the less lines of code that you have can be better as long as it's still readable. But that's
now,
pretty good there, right?
So in your cout here where you're declaring quotient equal to user number 1 divided by user number 2, does that only set that for that line of code?
No. In fact, notice later on when we did it like here, I set quotient here. It's C out there, but if I did it again here, it sees it. It stores it there. So like it's like erasing the
So if you in that cout line where you say user number 1 blah 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 and then in parentheses quotient equals and you declare quotient, if you then separately just printed or did a cout quotient, it would use that value?
Yeah, that's what we did here. 122 and 123. Quotient, set it here. I can do it up there if you'd like. Where are we?
No, that's fine. I didn't see that one down there. I'm sorry.
Okay. Okay, good. Yeah, so it stores it. It's like erasing the whiteboard and rewriting a number there. And until something's reassigned to it, that number is stored in quotient until it changes. So the only way to change quotient is to reassign a new value to it. And it'll
Roger.
stay that in perpetuity. That's it for the arithmetic demo. I'm going to run through a couple programs. I know some of you might have to leave early. They'll definitely be on there. I'm going to make we'll do a program to make a rectangular, calculate like the area of a rectangle, and then we're going to do a cone and work on both of those. Let me run that, close this one, and open up a new program. Okay. Oh, right click, Visual Studios. I want to start a new one. Create a new. All right. So, Jesus, I think, or Jesus, I think you were asking. So on the Visual Studios, I said create a new project. I'm going to look for empty project here. It might help to make this say C++. And then I'm going to say next. Let's call this my shape calculator. So I'm just giving it a name real quick. And let's get that out of the way. Add new item. We need to create a new item in the source files. We need a new source code. I'm just going to leave it as source for now. No need to do anything fancy. And what do we need to start off with? We should include the IO stream. And I'm going to using namespace std because I don't like typing std : all the time. And then we're going to start a new basic function, int main.
Is there a disadvantage to naming a namespace like that before you start?
If you've got a lot of people, not really. The only issue that can really arise is if you've got different namespaces and people have named the same like variable or same class or object in both namespaces with the same name, then it can be like, well, which namespace do you want me to pull from? Like if I use
Gotcha.
namespace std and then I create my own namespace, Professor Jones, and in each of them I make we'll do classes later on, but let's say I make a class for a rectangle in, well, I know std doesn't have one. Let's say I do a namespace for me and a namespace for you. I include both of them and we both make rectangle programs. And I try to include rectangle. It's going to say, well, which one do you want? Do you want mine or do you want yours? So that's where you need that scope resolution. For now, most people for the standard library just use the namespace like that. And that way, cout is assumed to come from there.
Okay.
Stuff like that.
And then the other question, you're returning on your main function, you're returning 0.
Yeah, when I return 0, what it does is it says, yes, press any key to close. It ends the program. It tells it, notice if I open this a little bit more. I've run the program. The executed was exited with code 0. It tells it to exit. Hell, let's see what happens when I return 1. I don't know what the other ones return. What happens when I return? I've always used 0. I don't know. I don't know what the. I'll have to get back to you on that.
So in one of the IDEs that I was playing with, if I didn't put that return in when I did open the integer function main, then it wouldn't compile. But in in Visual Studio, it compiles fine without that.
Oh shit! It's not supposed to. Oh, it might be a bonus feature of Visual Studios. They might go, oh, you must have just meant that.
Okay, so it's going to throw it in there if it doesn't see it.
Yeah, I think it's adding it in if it doesn't see it. Just like some of them, if you don't initialize a variable like an integer x equals 12, it assigns it the value 0. This program doesn't, but some of them do. So each of them have little perks. What we're going to do here, we are going to make a rectangle app, a rectangle calculator, and then a cone calculator. So what kind of things let's do rectangle first. Rectangle first. What kind of things do I need for a rectangle? What makes up a rectangle?
Length and width.
Length and width. Right? Is that good? Will that cover all rectangles?
Yep.
It's going to do a poor job of it.
4K.
Why?
Oh, because they're not all integer length.
That's right. In fact, most rectangles aren't integer length. So let's do double. Excellent. So what things could we calculate with a rectangle?
You could calculate the area.
We can do area. Anything else?
Perimeter.
Perimeter. Those seem like the main things right now. I don't know, unless we try to go 3 dimensions, then it's no longer a rectangle. We can do that. So what we did here, the rectangle first, we decided what things are variables. That's pretty handy. And we declared them. We haven't initialized them yet. Since we're making this like a calculator, I don't want to do a fixed value for them. So maybe I'll do cout. This program, we want a line that tells the user what it's doing. This program calculates the area of a area and perimeter of a rectangle. Always handy to tell the user what they're using. Maybe we should ask for the lengths of the sides now. What is the length? And we're going to do like we did before. We're not going to do an end line because we want it to appear on the same screen. And then we're going to use the input operator, cin, and we're going to say put whatever they say, we're going to store that in length. And this is a handy example of where we declare a variable before we use it, before we assign it a value. Then we could do the same thing again. So maybe I'll put a little space here. That's just the declaration of what we're doing. Here we're going to do it again. Maybe I'll do slash new line. What is the width? Why is that? Oh, there we go. Cin width. And even though I haven't done a whole lot, I'm just going to make sure that works real quick. I tend to procrastinate when I'm doing this, when I'm coding. And when I do that, and then it makes it really a bitch to find out what's wrong. What is the length? What is the width? I already don't like how it prints like that, so maybe I'm going to add another end line here at the end of this sentence. And I'm going to remove that one right there. I don't like that spacing. But I know that everything worked there, so it stores it there. So I can say double area equals length times width. And I could say double perimeter. The perimeter of the rectangle is you
Double
add
the
up the
length
size.
plus
So
double the width.
2 lengths and 2 widths, right? 2 times length plus 2 times width. And I could run it right there, but I'm not going to know if it worked because it's not seeing out anything. See, the area is, the area of your rectangle is area, cout, the perimeter of your rectangle is perimeter. And now I think that'll work. Does everything look good there? So what is the length? I don't know, 13. What is the width? 2.4. And it calculates my area and it calculates my perimeter. And it does it right below it. I think if I wanted to make this pretty, I'm going to put in another space there. I could do that. I could say end line here. Or I could use the /n. Now, notice, let's see what we got here. I've got 1 line, 2 line, 3 lines, 4 lines, 5 lines, 6 lines, 7 line, 8, 9, 10 lines of code to do that. Alternatively, I could have, we need the length and width up there. I could declare them up, the area and width up here too. I could declare area and width up here. And I didn't, but I should. And the reason why you should is it's a good programming habit to declare your variables when you can. That way someone that's reading your code knows what the What's going on? Why is it not like it? Comma area, comma perimeter. Oh, and I've already got them declared down here. So once I've declared them up there, I can do this down here. And it's going to do the same thing. The perks of doing it up above is that the programmers know right away, if you're working with someone's code and it's like 3,000 pages long, you know right away what the names of variables are. And so you're not like using the same name yourself later on. 3 and 7. Okay. So that can be a good programming thing. And now, rather than doing that, this was 4 lines of code. I'm going to comment that out and show you another way we could do this. We could do cout. I want that end line in there. In fact, I want a lot of that in there. So let me copy that. Rather than saying area here, I can do this. I can put length and width time calculation there. And I can put the perimeter calculation here. So this is option 2. I see I missed an H. Option 2, only 2 lines of code for the same thing that did 4 earlier. This is called refactoring. So refactoring your code to be more condensed can be helpful. There are pros and cons to doing this. If I wanted to use area or perimeter again, I would need to recalculate it this way. So if I'm going to use area more than once, store it. Store it as a variable if you're going to use it more than once. That's a good tip. Okay, we may have said, okay, we want to make this 3D. Give us a height, and we could do, well, the volume of a box is length times width times height. We could just do area times height. In fact, let's take a look at, let's do that. Cout. Let's make it a box. Please enter a height. Nope, I don't want to do an end line there, but I'm going to do an end line before it or a /n so it looks pretty. And I didn't actually declare a height variable yet, did I? So let's just declare height as a variable. And now we can do the cin height. And we can see out. I'm going to turn that area thing back on. Let's open that one back up. See out /n. The volume of the box is, well, we know it's length times width times height, but I've already done length times width. I could say area times height. Or I could say length times width times height if I didn't store area already. And I find it handy. I'm sure you've seen me doing it. I put spaces between this. All of my operations where I do plus or minus, multiply, divide, I think it's a hell of a lot more readable. Like if I look at perimeter without that spacing, if I just do this, why isn't it deleting? There we go. Oop. It's a plus. I don't like the way it's set. There we go. Delete. That's kind of harder to read, isn't it? 2 times length times, or plus 2 times width like that. If you put the spaces in, it's easier to read. Not only for everyone else, but it's also easier for you to read when you get some shit wrong and you're trying to figure out later on, what the hell did I do? Let's just see if this volume program works. I'll make it simple. We'll say the length is 3, the height or width is 2, and we'll make the height 1. Let's make it 10. And so it took the area. 6 times 10 is 60. It looks good. Although there is something wrong with that. 6 and 10 aren't very useful. 60 isn't very useful. You might want to make it clearer to your readers or whoever's using the program, you might want to say it's units or square units for area. And perimeter is just regular units. And down here, volume would be cubic units. Three, we can do 2, and it says it's 6 square units, or we could say units squared. I did that. Notice that the spacing I put in makes it, I put a space here, and it shows up well there. It makes it so it looks readable. You can do the height, let's say 100 this time. So 600 cubic units. So that's ways we can use variables and stuff like that. You can store them for later usage. They're pretty handy. Let's take a look at doing a cubic or a cone. Let's look at a cone. And so what's the volume of a cone? Let's just do volume. Let's not look at like surface area. Surface area's got more to compute. It's a little bit more of a pain in the ass. If you don't remember what it is, well, let's just go look it up. Volume of a cone. And pi r squared h over 3, or 1/3 pi r squared h. So I'm doing my shape calculator. So volume equals pi times r squared times h divided by 3. That's what it said. So let's go ahead and take a look at this. I'm going to comment out my rectangle stuff. I'm not going to delete it because I'm going to post all this stuff later on. If I remember, well, I don't need it. I'll leave that in. I'll comment out this part. Comment. So I can comment it back, uncomment it later on. Let's look at a cone. So what do we need for a cone? It said we need the radius and we need the height. And I commented out height. So maybe let's get rid of height there and put it up above with my things that I already declared. And I can put radius here, right, too? I can put it all at top where that we can see everything. So I don't need to do double here. So I do need to get that information from them, and so I need to tell them what we're doing, right? So let's see out. Let's find the volume of a cone. Please enter the height of the cone. And we'll say end line there. We can see in height here. Please enter.
Is there a library value for pi, or do you just have to declare however many figures you want?
I think it might show up in the C math library, but we're going to do it on our own here. And I'm going to show you a good way, a handy way of doing it. Please enter the radius. Let's see. So what is pi? Well, pi is 3.141526, some shit like that. Value of pi.
Shit like that.
3.14159, not 26. 159. That'll work. So I could use this here. And I could make a volume thing. But yeah, let's make the volume thing. Let's make a double for volume. And since I did it down here, I can just go straight to it, right? I can say pi. How do I do radius squared?
The up caret.
Let's try it. I like how you think. And then times, oh, r is not radius, it was radius. Gotta use the same variables, right? Times height divided by 3. See out. Ooh, it doesn't like pi. Why doesn't it like pi? I think pi listed as that is a value in one of the languages. So maybe let's call it capital pi. Why doesn't it like that?
In the suggestions, it popped up something with a pi in there when you first typed.
Well, let me try to do it up here. Oh, it's got pi. Oh, wow. This IDE actually has it stored in it already. Let's assume it doesn't. Let's call it MyPy. Not all IDEs have that in there. Why doesn't it like MyPy? So it's a constant, and it doesn't like it. What can I do about that?
Call it cake.
Let's try that. Let's try calling it cake. I know what I was going to show, and that might be a requirement of what I need to do.
Oh, no, never mind.
Still doesn't like it. Why?
Maybe it's because of the caret operator. Maybe it doesn't recognize it.
That's exactly it. So it doesn't like the caret operator. What else can we do for radius squared? Because it's not radius times 2. That's not right.
Just radius times radius.
We can do radius times radius. Let's do that. Now, we could include C math. And then there is a square function, a power function. Called POW. But that's more advanced. And not really necessary, right? We're just squaring. So see out the volume of your cone is, and since it's volume, it's gonna, we gotta say volume here. That was what we stored it as. I'm gonna say cubic units again. Keep it in the wrong key. All right, we don't have anything red underlined. It seems okay with it. Let's say, oh, let's use 10. In fact, let's use 10 on all of them. Multiples of 10 make it easier to do. So pi r squared h would be r squared would be 100 times h would be 1,000. Then we multiply it by pi would be 300 or 3,140 something. Divided by 3, that looks about right. I again don't like the spacing here. So I'm going to do this. I think doing a new line there, a couple new lines there. And I think I want to do a new line right here. And when I run it, I think it's make it a little bit easier to read. It is a little bit easier to read. I'm not a big fan of how close that stuff was at the end. I like doing this. I don't know if it makes it easier for you when you're coding, but we'll do it again. And now look at that big space. I can see where my code, what I was doing ended easier. Or, you know, seeing out a line of asterisks. Why don't you like that? Oh. I had less than. And so the asterisk makes a nice little line barrier too. Now, pi gets used a lot, right? If I'm doing volume of cone, and I might be using this with somebody else, there's a way that I can make this, I'll type this here. This tends to be used a lot. We're almost done. In fact, so much that I want to make it a global variable. Accessible to other programs or functions outside the main function. well, let's say other functions. Eventually, we'll have functions outside of it. We'll be doing those next week. And having a global variable is pretty handy. So I'm going to comment that out. And to do a global variable, global variables go before the main. And we tend to use all capital letters to let other users know this is a global variable. It's actually a global constant, right? It's not even a variable anymore. So I'm going to call it capital Pi. And if I do it before the main, I can say double pi equals 3.14. Oops. And it should get moody if I do that. I'm going to just check it real quick and see. Nope, it took it. Some of them won't take it. I want a space in there between all my includes and stuff like that, and where I put it there. I might actually make a comment here, global variable, global constant. I don't want someone coming in here. Notice what I could do. I could mess this up, though, the way it is. This is a global variable as it is. I could come in here and say pi equals 1, though. And now if I do the same function, if I run it again, it fucked up. It changed it, so it's not constant up there. To avoid that, we can say const. Notice it turns blue. Const is a command to make the following variable a constant. So if I do it out there, let me try to change it. Let's see if I can. Well, let's run it and make sure everything works. All good. 10, 10 gives me that 1047 that keeps showing up. So we've got const double. This makes it a global constant. This is a global constant, which we want. Pi shouldn't change. Ideally, because you might have different people using it, and some people are going to use more decimal places than others. We want to be consistent, so we'll declare it out here for use later. What happens if I try to change pi inside when something's constant? Notice it's got the red line. Const is a command to make the following variable constant. This is a global constant. It's going to get pissy if I try to change it. So this way you can avoid people using different values or changing it accidentally. And it's a handy step to take. So we covered our basic fundamental data types today: integer, double, float, char, and Boolean. We didn't do a lot with Boolean yet, but we will. We're going to do strings on Monday, and we'll do some functions on Monday as well. We took a look at a couple programs. We did a rectangular one. Let me uncomment the rectangle problem. Uncomment. And then we did a cone problem. And did the same thing with a cone. We used a variable. We took variables and had inputs for them. Let the user input them in. We talked about making a variable a constant so it can't be changed. And these are handy ways to go about doing it. Any questions for today's lecture?
Yeah, why are we doing this all under an integer?
Like right on the main.
Yeah.
There are other ones you can use. You can use void. You can void main. It's just a handy one to do when you're not requiring a return. It should
Okay.
work just as well with void. Oh shit. It's a global constant. If I make it void main, I don't need the return type. And it should run just as well. I've uncommented the rectangle thing though, so it's going to go through all of it. You know another thing I don't really like? I don't like how close that top line is to that the command box up there. That may or may not show up on the app, whatever they're using. But sometimes I like to just put in a new line in the beginning. So we can do void main. Let's make a little comment about that. I'm glad you asked. Int main is not required. If you use void, delete or comment out the return line. Return 0 at the end. Now, when we start doing functions on Monday, that thing's very much going to matter what we put out front. Because later on, just to give you a little taste of what we're doing, in fact, let's do it here. Let's say I'm going to make a function that I want let's see, the rectangle, the area function. We want it to return a double, so I can say double rectangle, and I can tell it to take in a double length. I'll just use L and double H. And then we do the grouping braces to show that we're doing something here. So this is a function. We'll do this a lot do this in further detail on Monday. And what this is doing is taking length in and height in as variables, and it's going to return a double. So I can say area, or I want to say area is a double, so double area equals L times H, and then return area.
So is this going to ignore your declaration of area under the main?
This area, they're completely different. The only thing this rectangle, well, let me finish programming it up. When you do it at the bottom down here, this is where we're actually coding it up. You have to do something called a prototype at the top. So before the main, I'm going to do a prototype of the function. Rectangle function here. And we just say it ends with a colon. We're telling it later on what this does. It says later on you will find, after the main function, you will find a rectangle function that returns a double and requires 2 doubles input. And now if we use that, where I did area here, I actually don't need area. I can say, instead of using that area, I can say, oops, get rid of the commenting, area equals, I'm going to use the rectangle function. I'm going to pass in the length. I'm going to pass in the width that we just took. So this is a function like f of x comma y kind of thing, a function of 2 variables that returns the area. In fact, I like that so much, I'm going to take that and put that down here in my rectangle code. as a description of what it does. So notice now I don't have area declared other than right here. I said area is going to be the result of this rectangle thing. And we wanted to do area there, so I'm going to do area there. Did I use area anywhere else? Yeah, area is down there. So I'm going to run it. It's going to give us rectangle and cone. Let's just use 10 on everything. Makes the math easy. My rectangle is 100 square units. Perimeter is 40. That makes sense. If we do another 100, it should be 1,000. We'll do the height is 10 again. Radius is 10. And it worked. It computed the area, right? It gave us back 100. But the only spot I have area calculated is right here. In fact, let's go back to calling this length times width. And let's call this area 2. And then these two things do the same thing. Area 1 and area 2 do the same thing. And even better, if you wanted to refactor, let's just copy and paste it again. Rather than calling on area 2, you can do the function call. That's what it's called here. I can do the rectangle length width there. So this is actually a function call. We're calling the
Can you
function f of x.
scroll down to your function?
Yeah.
So why are you declaring double L and double H instead of length and width there?
I was trying to illustrate that that doesn't matter, but we can actually say length and width. In fact, I don't know why I chose H, to be honest. That was just me having volume in my head.
No, it's fine. I was just curious what the...
That was... I could call it anything. I could call it X and Y. It is... H
Okay.
was a terrible thing to use. In fact, I'm glad you said it. It's helpful to use things that are reflective of what they are. So someone reading this later on, just like you were reading, you could have, why the hell are you using H? H is height. That happens when you're working with other people, and it's good to use language that's clear. In fact, length and width is better than L and W. The point was, I wanted to make it clear that this name
does not need to match your variable.
It just has to match what's here. It doesn't need to match what's above. So I called length here and width here. I don't need to call it length and width here. I can call it X and Y if I want to.
Okay. So this down here, you're just defining what that function is. It doesn't matter what any of the other variables in the system are.
Right. So when we use functions, nothing in the main is used here except what we pass in the function call. And that's in this case, length and width.
Okay.
In fact, doing, if we did let's do the volume thing here. I'm going to copy this. I'm going to come down here. Let's make a double volume of cone. And it's got to take in a radius. It's got to take in a height. And then we use the grouping brackets. I'm going to just post that there. Double volume equals pi times radius So everything that we needed was passed in, radius and radius and height. Pi is a variable. Pi is a variable, but we declared it to be a global constant. So it doesn't need to be passed in. And now if I want to use it here, I could say, rather than calculating volume here, I could say volume of cone, and I got to pass in radius, I got to pass in height. And there's one more thing I haven't done, and that's to make a prototype up top. So I'm going to copy this copy the everything except the curly brace, go up top, and do a prototype up here. Now when we do it, I don't have the volume declared anywhere except for right here. In fact, I'm going to change this to say rad. And HGT is a common one for height. Just for when I post these lecture notes in the announcement, it's clear that the names don't have to match. The only spot that it has to match with the radius and height is up here where I used it.
Your prototype as well, right?
Yeah, prototype as well. Well, no. In fact, I can just say double and double.
Okay.
But that's not good programming, simply because when other people use it, they could go, well, what the hell are the variables that you're passing in? And these don't even need to match what's below. This should still work, even though it says rad and HGT down below. This should still work. Let's run it and make sure I'm not just talking out my ass. Clearly, I'm talking out my ass. What's the problem? Oh, I don't have a return. Fail. I'm gonna go back up there and change that just to illustrate it. And the prototype, different name. I was pretty sure. Only having one of them like that works too. What the hell? Why is it? There we go. Just using 10 for everything. We showed doing area a couple different ways with a function call or by calculating it in the thing. And we did the radius of the cone, and here's our volume, and it did we sent the radius and the height to the radius or the volume of cone function. And it returned the value and printed it out there. So this was here. We did a function call for volume of cone function with two input parameters, radius and height. All right, let's call that, oh shit, it's already 6:06. Let's call that a wrap. In fact, we got a good jump start on functions. We will delve more into that on Monday. We will cover strings on Monday. But I think we learned a lot today. We got any more questions before we call this a wrap?
Did you say the set precision does or doesn't round?
Set precision sets the rounding. It did round. Set precision rounded. So let's make a note of that. It's pretty handy. Shit. That was in the other one. Let me do it in the other one. So set precision, wherever it was, I'll put it at the top. Set precision rounds. But the modulo operator does not. Okay.
Is there,
Okay.
can you use like a value or a variable in set precision so that it effectively relies on the user for significant figures?
That's a good question. Let's give it a try. Where was set precision? Set precision is there, right there. Let's do that. I'm gonna say let's make it an integer, right? Integer makes sense. Let's do right here. Int decimal places. How about that?
Okay.
And we'll do a cn. Please enter the number of decimal places. Should work.
I was more referring to.
Hold on, that's a C out. Go ahead. Sorry.
I was more referring to looking. No. I was just more thinking the referencing the value that is entered for. Does that make sense? So like if you enter 3.332, then it's going to be 4 sig figs. If you enter 3.3, it's going to be 2 sig figs.
Oh, sig figs.
Like actually reference instead of declaring what are you having the user declare what they want for decimal places, looking at the values that the user enters and determining sig figs off of that.
You have to program that in. You would have to program it in, and we can look at something like that later on. That's a great question. In fact, let me make a little note. That might be a fun lab to do later. Shit, I'll make a note in a second. I don't have a notepad here. We will do it. We'll make it an in-class experiment some point later in the future when we're ready for that, where we will extract the number of decimal places that it shows, hopefully, and use that to calculate sig figs. And then we can make it apply to the calculations. Like if you entered in, 2 sig figs on one number and like 4 on the other, you only want to use the lowest number of sig figs. At that point, set precision to the lowest amount. That's going to require us to look at different values and doing comparisons. And we haven't gotten to the comparison operators and using them yet. And like if those are a condition, if one value is less than the other, use this one. We'll get to that kind of stuff, but we'll do that as an example. I like where you're going with it. But
okay.
What I originally thought you were asking is, can we just set it here? Now, when we programmed this up, we did 8 places, but if I wanted to do 2 decimal places, because we're like talking about money, it changed all the decimal places to 2.
Okay.
And even on the quotient, stuff like that, all the decimal places are set to 2. So we can have them do it there, and we can program up a sig fig thing later on.
Cool.
Any other questions, anybody? All right. Peace out.
Peace.
Let me stop recording. And I want to
Recording stopped.